Scientists classify Earth as a terrestrial or rocky planet, along with Mercury, Venus, and Mars. Our next guest is an astronomer and an astrophysicist, and he takes us on a tour of these 4 planets that are closest to the Sun to show us how they demonstrate the magnificent work of our Creator. Coming up next on Origins, the terrestrial planets with Dr. Jason Lisle. Hello, my friends, and welcome to Origins. My name's Don Chapman, and it's my privilege to be your host. During this program, we showcase interesting guests who present evidence from science along with other important facts validating the truth of creation and the accuracy of the Bible. Today's guest, Dr. Jason Lisle, has a PhD in astrophysics from the University of Colorado and is the author of Taking Back Astronomy: The Heavens Declare Creation. He was instrumental in the development of the planetarium at the Creation Museum in Kentucky, and he currently works as Director for Research at the Institute for Creation Research in Dallas, Texas. Dr. Lisle, we are so delighted to have you here with us.
Thanks for having me on.
It's wonderful. You're one of my favorite guests, and today what are we going to do?
Thought we'd take a look at the planets of the solar system,
okay,
and particularly the inner planets, and
right,
maybe we'll get to Jupiter, time permitting, but we'll look at those
How many are in
ones.
the inner planets?
There are 4 inner planets, and they're called terrestrial, which means Earth-like, basically.
Okay.
Because they're similar in some aspects to the Earth.
So this is Earth and its 3 closest neighbors.
That's right, exactly.
Wonderful.
And in increasing order from the Sun, they're Mercury, Venus, Earth, and Mars. And so I thought we'd just take a look at these, and of course I'll have this computer simulation software here that will allow us to look at these in detail.
What a neat thing this software is. It changes the way we look at everything.
It really does, and it's very accurate too. It's what I appreciate about the folks that wrote this software. Here we have Mercury, for example, and you can see that Mercury basically looks a lot like the Moon. It's a cratered world. It has no substantial atmosphere, maybe a real thin, but nothing substantial. And that's why you can see the surface is very cratered. It's got all these impact craters. There's nothing to stop it. Of course, objects that would impact Earth tend to burn up in our atmosphere. And so
right,
we have that nice protective atmosphere.
The atmosphere protects us.
That's right, it does. Mercury doesn't have that. And so that would be a little bit dangerous if you were there. Another issue would be the heat. Mercury is 3 times closer to the Sun than we are. It's about 1/3 the size and 3 times closer to the Sun. And that means if you were on the day side of Mercury, the surface temperature would be close to 800 degrees Fahrenheit.
800 degrees.
Yeah, so bring your sunscreen. Yeah.
Wow.
And then on the night side, it drops to, a couple hundred degrees below 0. So it gets very, very cold on the night side. People don't realize that.
And it's part of that because the atmosphere buffers our temperature.
That's right.
It has no buffer.
That's right. There's actually two reasons for it. One of them is the atmosphere.
Okay.
There's no atmosphere to even out the temperatures. And the other reason is it's a very slow rotator.
Oh.
Yeah, Mercury rotates very, very slowly.
Like a
I think
rotisserie.
Yeah, very
yeah,
slowly. So one side really gets baked, and it takes something like, I think it's 58 days for it to for it to rotate.
It is slow.
Earth days, yeah. So it's very, very slow rotator, and for that reason, the day side just bakes, and the night side just freezes. And of course, it is interesting that if you landed on the night side of Mercury, of course, you could have a spacesuit that would protect you from the cold temperatures potentially. But if you landed on the night side of Mercury, if you crash landed, okay, you can't get off. You're in your spacesuit. You're in your spacesuit. As long as you run west, you could actually keep ahead of the sunrise. It would be possible to run fast enough.
The rotation's so slow
that's right, you
that
could outrun it.
A jogger could stay out of the heat.
That's right.
Till he got tired.
You can't stop though. You can't stop because once you stop, the sunrise just catches up and then you're gone. So it's one of those little interesting factoids.
How long can you tread water? How long can you jog?
Exactly.
That's it. Yeah.
Exactly. So it's a neat little world. It's again, it's smaller than the Earth, about 1/3 the size of the Earth, and you can see it's just pockmarked with craters. And for a long time, we didn't know what one side of Mercury looked like because we sent a spacecraft there in the 70s, and it went past Mercury and mapped one side, and then it was in such an orbit that every time Mercury orbited twice, it would come back around and it mapped the same, but it got the same side because of the way Mercury rotates.
Yeah.
Mercury rotates, let's see, it's 3 times every time it orbits the Sun twice, and so they got the same side every time, interestingly. Another interesting thing about Mercury is it has a slight magnetic field. And that's interesting. Of course, the Earth has a magnetic field that causes your compass to point north, and that's caused by electrical currents in Earth's core. Mercury has that too. Mercury's is weaker than Earth's, but it's there. And that's surprising from a secular perspective because magnetic fields decay with time. They naturally run down as that electricity encounters resistance. The magnetic field decays. And we actually have good evidence that Mercury's magnetic field is decaying just like we'd expect because we sent another spacecraft there more recently. The Messenger spacecraft flew past Mercury, measured the magnetic field, and there are indications that it seems to have dropped since the 70s.
Oh,
so we've actually been able to measure.
Rapidly.
Yeah. And we'd expect that based on known physics. But the interesting thing is that's only compatible with a biblical worldview.
Oh,
because you see, because the magnetic field decays so rapidly that in 6,000 years, yeah, it would be about this amount. But if it's billions of years old, it would be gone by now. It should have decayed a long time ago. And so
that's fascinating. The rate of decay is a constant.
It's an exponential decay, but we think the exponent is constant based on our understanding of physics. And so that means if you run it back in time, the magnetic field would have been outrageous if you push it back beyond 1 million years or something like that.
So it's an argument for a young Earth.
It is, yeah, or a young solar system even.
Yes, yeah, I mean young solar system, sure, excuse me.
So it's an interesting little world. Again, we can see it rotating here as I speed up time, but you can see it rotates very slowly, and it's actually orbiting the sun significantly as it rotates. And let me change the orientation here a little bit so we can see that.
You would almost think the tremendous heat that one day it would just kind of burn up.
Yeah, although it doesn't have flammable type of elements that it's made of. It's mostly rock, and rock can withstand a lot of temperatures. But that's one reason why it doesn't have much of an atmosphere. Any atmosphere would tend to boil away. So that's Mercury. And it's an interesting little planet. It's hard to see because it's always very close to the sun. And people might have seen Mercury without knowing it. It would be just after sunset or just before sunrise. It'll appear as a little star, depending on where it's at in its orbit. And it's a little hard to see. So let's go to the next planet, Venus. Venus has been called Earth's twin because it's about the same size as the Earth. And that's about where the similarity ends. It's other than it's solid. Okay, so it's got a solid mass on its surface. But that's kind of what Venus looks like. You can see it there from space. Venus is very easy to see. Very easy to see from Earth. In fact, it's the third brightest object in our sky. You got the sun, you got the moon, and Venus.
And you got Venus.
Yeah, in terms of the naturally occurring objects that are regular objects. And you can often see it in the evening sky as a very bright star in the evening sky or in the morning sky, depending on what part of its orbit it's in. So that really object, and people look at it, man, that's a bright star. It's Venus. It's Venus. And it's one of the stars that's mentioned in Scripture as the morning star.
Oh, it's the morning star, the bright morning star.
That's right. That's right. That's Venus. So it's a lovely planet. It's beautiful to look at, but you probably wouldn't want to go there either.
Kind of looks like an egg.
Yeah, it kind of does a little bit. It's got that kind of yellowish color, and that's because that's clouds that you're seeing.
Okay.
Venus is permanently...
It has an atmosphere.
It has a very thick atmosphere, much thicker than Earth's, 1,000 times something like Earth. It's very, very thick. And those clouds that you see there, they permanently enshroud Venus. And so you would never see the sun on Venus.
Wow.
It would be permanently overcast. And growing up in Ohio, it was kind of like an Ohio winter, really.
What's the temperature?
The temperature, interestingly, is actually hotter than Mercury. The temperature is 900 degrees Fahrenheit.
And why is that?
And why is that?
Because it's further away.
You'd think it'd be less, but it's because of a greenhouse effect. That atmosphere traps in the heat
Cooks it,
and basically cooks the surface. Yeah. And we've landed, actually the Russians landed some spacecraft on the surface of Venus, and they lasted for a little while. They were able to take a couple pictures before they gave out, because it's hard to make something that can survive in 900 degrees Fahrenheit temperatures. But it's really interesting. In fact, the atmosphere is very, very thick. It's so thick it actually bends light significantly. And that would have the effect, it would make things look distorted. If you were standing on the surface of Venus, instead of the world going down, because it's a sphere, it would seem like it's going up. It would feel like you were standing in a large bowl, because the surface would seem to go up. Isn't that strange? Because of the way the light bends.
Yeah.
But that thick atmosphere is what really makes Venus kind of interesting and unique in terms of the inner planets. Now today we can penetrate that atmosphere and with radar, and we know that the surface of Venus looks like this.
Oh.
So it's a really interesting surface, and we can watch and see how Venus rotates with time. Venus actually rotates backwards and very slowly. Its day is actually longer than its year, interestingly. And let's see if we can get this, make sure we're turning the right way here. There we go. Let me spin it around here. Yeah, that's right, that's right. So there it is rotating backwards. And you can see it's orbiting the sun the same direction as the other planets, but its rotation is the opposite. and so the day actually being longer than the year
Do we
in terms
know
of
what
its
causes
rotation.
that? What would make one planet rotate one way and another way?
There's only one explanation as far as I know, and that's God is creative, and He's given these planets different spins. I don't think there's any secular
There's no
explanation
natural
for that.
explanation,
Yeah,
just God made it that way.
In fact, in the secular view, the planets really ought to be aligned. They ought to be the same and rotating at about the same speed in the same direction. And that's the expectation of the secular model, and few of them do, really. I mean, a lot of them are different, and usually they invoke a giant impact to say, well, something hit it and changed the rotation. But Venus is almost exactly upright. It's just backwards.
Yeah.
It's just rotating backwards, and so that's contrary to what you'd expect, really, in the
Continues to
secular
point
model.
to a designer, creator who just said, because I'm an artist also, I'll just make this one go this way.
That's right. That's right.
Isn't that awesome?
I mean, the solar system, some things need to be a certain way for the solar system to work.
Right.
And so it's probably a design feature that the planets all orbit in the same direction so that there are no collisions, for example. And so that makes sense. But they can rotate different directions, and Venus does that. Now, again, we mentioned the surface temperature is not very pleasant. And also those clouds that cover Venus are sulfuric acid type compounds. So there's just lots of wonderful ways to die on Venus. It's not a place you'd want to visit, really. Yeah. It has no moons, and it has no liquid water or anything like that. Of course, it couldn't, water couldn't exist in a liquid state with that kind of temperature. So it's Earth's twin in name only and in size only. It really is about the same size as the Earth. But that's where the similarity ends. Other than that, it's a toxic world. And some people say, well, why would God create, with thick, a poisonous atmosphere like that? Well, we're not supposed to go there, right? I mean, Venus is designed to do what it does, and those clouds that would kill you if you were there make Venus very reflective, and they make it one of the most beautiful objects in our nighttime sky. Yeah. So it really is stunning.
The morning star.
Yeah. Now the next planet out is Earth.
I've heard of that one.
I've heard of that one too. And all the best restaurants are on this planet right here.
Is that right?
And everyone you know or ever will know is on this little planet right here. But Earth has a number of interesting features that are unique just in terms of a planet because it is designed for life. And so, of course, it has liquid water on its surface, which we think is necessary for any kind of life to exist. And Earth's covered with liquid water. That's one of those ingredients for life. Earth also has plate tectonics. As far as we know, it's the only planet that has plate tectonics.
Is that right?
Yeah. And we think that that's also a design feature because we think the mechanism that God used to flood the world and then to establish the world again after the flood of Noah. We think actually the continents were probably together before the flood year and then pushed apart. And so God flooded the only planet that really could be flooded, and in a way that He designed the planet to be able to do that. So it's kind of interesting that it's designed with just that feature in mind.
It seems to me the evolutionists are desperate to find water somewhere else.
Yeah.
Because water really is linked to life, isn't it?
It really is. And they would say, well, where you find water, hey, life probably evolved. Well, no. You can have water out in space. And the water molecule is actually pretty common in space, although Earth's the only place we know of where it's abundant in its liquid state. But it wouldn't surprise me if they found liquid water somewhere else in the universe. It's a big universe.
And it really wouldn't prove anything.
No, it wouldn't. It wouldn't. And I would not expect really to find life out there. The Earth is specially designed for life.
Right.
In fact, the moon actually stirs up tides on Earth's oceans, keeps the oceans from stagnating. Yeah, and so it has that cleansing effect. And so it really is designed for life. It has those special features. Now our next planet out is Mars. I'm not going to spend a lot of time on Earth since we live there. I figure people probably know that one pretty well. Mars is probably the most Earth-like planet in terms of if you wanted to go there on vacation, Mars would probably be the one to pick. You'd at least have a chance of surviving if you brought your spacesuit and enough food and water and so on, because Mars is similar. It's not similar in size, about half the size of the Earth. But the temperature, it's a little too cold, but it's not astronomically cold. It's just a bit chilly there.
What does a bit chilly mean? Put some numbers on
well,
that.
it could get above freezing at some times.
Is that
in the
right?
Summer.
Okay.
Yeah, it could actually get above freezing. And it has polar ice caps, and you can see there the northern polar ice cap. And it's got one on the south as well. And they change like Earth's polar caps grow in the winter and then they shrink in the summer on respective hemispheres. Mars does do that too, just like that. Mars has seasons. It's tilted about the same as the Earth, so it would have seasons about the same as the Earth.
Seasons.
Mm-hmm. The year is about twice as long as the Earth's. So, but other than that, you're a little bit further away from the sun. The sun will be a little darker, a little smaller in your sky. But the rotation rate's similar to Earth, 24.5-hour rotation, which is kind of neat because you could get up a half an hour later every day and it'd never catch up with you. So it's kind of neat. It's just got that little extra half an hour that you could sleep in every day. So that's kind of a neat feature.
It has been the place that's captured the fantasies of the science fiction world.
Yeah. And that's because it is most Earth-like.
similarities.
Yeah. It has volcanoes on its surface, mountains. In fact, you can see, let me rotate it around here, you can see some of these volcanoes. Some of these features you can see from Earth with a large telescope, in fact, but especially these volcanoes here. You can see these large, you see those right there, those large, looks like big pimples. Well, those are actually large volcanoes. In fact, this one over here to the left is Olympus Mons. It's 3 times taller than Mount Everest.
Are these active volcanoes?
They're not. They're thought to be extinct, but it might be that they're just dormant. Some creationists think that these could erupt at some point in the future. It's possible.
And if they erupted, would it affect us in any way?
No, it would not.
Okay.
No, but it would be a spectacular.
It'd be something to watch.
Yeah, it would be something that would be indicative of biblical creation, because the secularists think Mars is billions of years old and therefore dead and should have no volcanic activity. But we think it might still have some.
Wow.
We think it's still possible. There are canyons on Mars. Here's a massive canyon. See that big, looks like a scar along the surface?
Right.
That's the Valles Marineris Canyon. It's much bigger than the Grand Canyon of the United States. In fact, that's about as big as the United States is across.
Wow.
Just to give you a feeling for that.
The whole way across
Yeah.
the country.
So it's really amazing. Yeah. So it's a wonderful little planet. Now, again, not quite right for life, because the atmosphere is carbon dioxide and very thin. You couldn't breathe on Mars. You'd have to bring a little bit of Earth with you. You'd have to bring your spacesuit, a little bit of air. No liquid water on the surface as far as we know. The conditions aren't quite right to support liquid water under most circumstances, but there's evidence that Mars once had liquid water on its surface, dried riverbeds and such. So it really is an amazing little world, and it reminds us that God is creative in the way that He creates these different planets.
He sure is. We're going to come back to that in just a minute, but we have to take a break. We have an incredible God. He's an engineer, He's an artist, and He's a creator. And we're going to talk about it when we get back. Don't you go away. We are back with Dr. Jason Lyle. And Jason, I've always wanted to say this, so I'm going to get to say this. When we left, we were on Mars.
That's right.
So take us back.
Okay. We're talking about Mars and how it is Earth-like in some ways.
Right.
The polar ice caps, they're actually made of carbon dioxide, frozen dry ice.
So it's
some
not
water
ice like
right.
our ice, it's more like
Yeah.
dry
So
ice.
There's some water ice too, but it's mostly carbon dioxide, frozen carbon dioxide,
Okay.
dry ice. And water would have the same effect on Mars that carbon dioxide does on Earth. Dry ice, you know, it doesn't go to a liquid state, it goes directly to vapor. Water would do that on Mars because there's insufficient atmospheric pressure to keep it liquid.
Oh.
So yeah,
That's
so it's kind of
amazing.
interesting.
Yeah.
A little bit of an atmosphere, so you'd have a blue sky, interestingly, sometimes. And sometimes the wind will kick up the dust and you'll get a pink sky. And so it depends on the time of day and you know, the local conditions there. But otherwise, it's kind of similar to Earth in that
And
respect.
we would have that if we had a dust bowl.
Yeah, you could have something like that.
during
on
the-
Earth. Absolutely.
yeah.
Mars has 2 moons, interestingly, and I wanted to show you these because they're kind of interesting to me. They're very different from Earth's moon. And we'll go to Deimos first. That's number 2. So Phobos and Deimos are the names of Mars's 2 moons. And the names mean fear and terror. And that's because Mars is associated with the god of war, and fear and terror go along with war. So when these were discovered, they were named after that. And there's Deimos, and you can see it's a weird-looking little moon, isn't it? And if we speed up time, you can watch it rotate around like that. And you can see it's one of the first things that surprises people is, wait a minute, it's not round. It's not
That's
a
right.
sphere. And smaller moons tend to not be round. This moon is only it's less than 10 miles across.
Okay.
It's not it's basically a big boulder in space. That's what it is. And it orbits around Mars. And it takes something like a day for it to orbit Mars, something like that, around 30 hours, I believe. And it just looks kind of like a big potato there floating in space. Really interesting. And so that's Deimos, the outermost of Mars's 2 moons, the outer of the 2. Now the inner one, Phobos, let's go to that one next. If we zoom out here a little bit. And there's Phobos on the other side. You can see these moons in a small telescope if you really know what you're doing, if you really know how to look for them. They're actually pretty bright, but Mars is 200,000 times brighter. And so it's a contrast issue. You have to in order to see these well, you have to kind of get Mars just off to the side of the telescope so the glare doesn't get in the way. And I've seen both Phobos and Deimos in a small telescope, little specks. And again, Phobos is just a little bigger than Deimos. It's only about 10 miles across. And you can see there, it's got a huge crater on one side of it. Looks like something hit it really hard. So really fascinating.
Now, our moon, we can see in God's creation plan that it has function. It creates the tides, which clean the ocean and things.
Right.
Is there any function known to these moons?
We don't know what they're for, what they do, other than it's I think, an example of God's creativity. You know,
Sure.
Mars has 2 moons. Their gravity's not nearly sufficient to stir up any kind of tides. Of course, Mars doesn't have oceans anyway.
Yeah.
But their gravity would be insufficient to stir up tides. So you see, Mars doesn't have those design features that are right for life on
Right.
Mars, because it's not designed for life. It really isn't. But nonetheless, they're interesting, and it gives us little examples of interesting physics. For example, if you were on the surface of Phobos, the gravity there is so weak, you could pick up a rock and throw it into orbit.
Oh,
It'd
my.
go around, yeah, and you better duck because it
could
come back
come around
and
and
hit
hit you
you.
in the
Or
head.
you could play catch with yourself.
Sure,
You could throw it that
yeah.
way and then catch it like
over
that.
here. You keep
So,
practicing.
Yeah.
Make
So,
for an interesting baseball game.
and it orbits very close to Mars, so you can actually see. You can actually imagine looking up at the night sky and seeing Mars like that just up above you. I mean, it would be just spectacular.
Yeah.
So it's a fun little moon. It's a fun little moon to enjoy. So anyway, that's some of the characteristics of Mars. You can see it's got some things like the Earth, but some things quite different and not quite designed for life. And so all of this, you know, as we look at these different planets, it reminds us that we really do live on a very special world. A world that, according to Isaiah 45:18, God formed it not to be a waste place, He formed it to be inhabited. And these other worlds, not quite right for life. Mars is the closest, but even it doesn't have that protective magnetic field that the Earth has. It doesn't have the right kind of atmosphere. It doesn't have liquid water. It doesn't have those characteristics that are necessary for life. And that just reminds us that we really live on a special planet.
God designed all of the planets, but He fine-tuned Earth, didn't He?
He really did. In fact, if you think about it, God took one day to make all these other planets and stars in the creation week. 5 of the 6 creation days are working the Earth, making it right for life. Not that God needed time, of course, we understand that. But I think to show the Earth's special significance.
He was teaching the importance of that, yeah.
That's right.
The intricacy of everything that has to be fine-tuned to make life possible.
Exactly.
Is an amazing thing that nothing else you look at has.
That's right.
Yeah.
That's right. None of these other planets exhibit quite those features.
Very good.
Yeah.
Well, where do we go from here? How do we wrap this up?
How do we wrap it up? I think we just want to remind people that there are 4 planets that are the inner planets that are Earth-like. And we've seen Mars here. We've seen that if you land on one of Mars's moons, you get a spectacular view of Mars. We've seen that Mars is similar to the Earth in some ways, but different in some ways. And the similarities remind us that that God is a God of unity, but also a God of diversity. And so what we see in these inner planets is exactly the characteristics that we'd expect, given a God of diversity. And by way of contrast, and maybe as a little bit of a preview into another program, I just want to contrast this with one of the outer planets, Jupiter. Because you see, these inner planets are Earth-like. They're called terrestrial, meaning Earth-like, because they are similar to the Earth in the sense that they're solid, they have a surface you could land on. If you could somehow protect yourself from the heat of the inner planets or the cold of Mars, you could theoretically stand on these worlds. And that's very different from Jupiter, for example. Jupiter's a ball of gas. There is no surface on Jupiter. You could not land on Jupiter.
Surface.
Yeah.
Could you fly through it?
Theoretically, you could fly through Jupiter. Now, the gas gets very, very thick and it becomes liquid at some point, and so it'd be like going through molasses. But theoretically, you could do it.
It never gets solid.
Yeah.
That's amazing.
And so these outer planets are very different from the inner ones. And again, that reminds us of God's order, His unity, and His diversity. We have these planets that are like the Earth, unified, and these planets that are very different from the Earth, very diverse. And that's characteristic of the God that we serve. It's something that's built into the universe, and into life for that matter. The different kinds of life forms that we see on Earth, the fact that we can classify them, into kingdom, phylum, class, order, and so on. People think, well, that's because of evolution. That's why there's similarities and differences. But you can't argue that with the planets. The planets did not evolve from a common ancestor, and yet they exhibit similarities and differences. And so that's exactly what we'd expect given the God of creation, the biblical God who made each of these worlds and designed them to ultimately to reveal His glory, to glorify His name, and for our enjoyment, I think, as well.
I think you're right, for our enjoyment. I'm going to ask you this. We have a minute. Are we ever going to go to Mars? I don't mean you and I, but
I'm not.
humanity. I'm not either.
Some people it might be possible for people to go to Mars.
Of
It is a goal. There's the, I think it's the Mars One program, or they actually want to start a colony on Mars. I have to say, it's dangerous. It's very dangerous to put people that far away. I mean, we went to the moon, but the moon is close, very close compared to Mars. Mars is much further away. The moon was a few days away by spacecraft.
Right.
Mars is 6 months away by spacecraft, minimum.
And so if there's trouble, you lose those people.
That's right. And it's a terrifying thought, because human life is so precious, of course. Now, I'm not against a trip to Mars. I'm just saying There's caution. There's got to be a lot of caution, because if you don't have the medical facilities there. If something goes wrong, you got to be prepared to deal with it.
And what's the takeaway if we do? Just to sort of say we did.
There's not much. Yeah. There's the coolness factor, but there's not a lot. Yeah. Most of the science we can do with unmanned spacecraft more efficiently and cheaply.
Jason, I have to say I love the lenses through which you look at our universe and our solar system. And I love the perspective you have that all of this really does declare the glory of God. It shows His diversity. It shows, like to make them all spin one way and one spin the other, just to have people sit around and say, I wonder why you did that. And the beauty of it all and the splendor of it all is remarkable. And I love how you see God in all of this. So thanks for sharing that with us. And folks, as we've been looking at the planets together, I hope too that it has enhanced your worldview to see God the Creator, God the Designer, God the Engineer at work in all of this. Always remember, my friend, that it's God's view that He created you. That should be your worldview too. Hope we'll see you again soon here on Origins. And until then, God bless you, my friend.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file from our website at www.originstv.org. Or for a DVD of this series, you can order online or send a $12 donation to cover shipping and handling, and write to Origins Program Number 1502, Cornerstone Network, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and financial support of you, our Cornerstone family.